Now, this one's a new one to me, and I'm sort of wondering, why am I doing all these silly nuanced labs? And I'm thinking, what's the point of this? But the thing is, what's the point of most things? They're usually quite critical. So this one here ends up being an amplifier. And so I'll talk about that in the last questions. And that was used to amplify signals that telegraphs across the Atlantic. So in a wartime situation, that could be life and death, knowing what's going on and making the correct decisions. So a lot of these little nuanced things had real historical value, but we've got to remember in all of this that they're just light waves, and that's useful for everything, including on the internet and signaling and stuff. But they're also applicable to every other thing on the electromagnetic spectrum. So it could be X-rays or gamma rays or radio waves. So all of these principles will apply to endless applications. Okay, so it is actually quite critical. And so in this one here, they just asked you to rotate the mirror by a certain degree and then see what the reflected ray is. So I just drew all those in and did all the rays. And so what I find here, and I just double checked it, is that you rotate the mirror by a certain amount and it's actually double. So this is amplifying it by 2. And then I'll do the distance greater the difference also. And so here I was just checking, well, does it go crazy if I take it like a real long distance? And no, it just doubles it again. Okay. And then they lead you into questions. Ask your teacher to show you a spot galvanometer. Was this written like 100 years ago or something? I don't know. I got the laser out, and you can see that I've moved it like a millimeter at the most, and then about a meter or two away, and because of it radiates out like a circle basically. I then measure the difference between the two, and it's like 35 centimeters. So that's amplifying it like 350 times or something, on top of the doubling as well. So you could easily get like 1,000 times amplification just from light. And so there's a modern galvanometer there, but this is sort of the setup we've got. It's a little bit more simplistic. So seeing the current differences, the current will cause a magnetic field. The magnetic field will turn the magnet a little bit, so the mirror turns a little bit, and then you get this huge amplification. So go watch the electromagnetism videos if you don't know how magnetism and electricity interact. But now we're using that with light as well. Big combo.